So today we will be starting deadlock topic. So to understand the deadlock, we must first understand what exactly deadlock is. So deadlock is a situation. We all know about the processes because a process is program in execution. So in a real world scenario, we see a lot of processes are happening together. I mean, they are working together to do some particular task. So deadlock to understand the deadlock, we must understand what is exactly deadlock. So deadlock, if two or more processes are waiting. So what happen if I'm saying that if two or more processes are waiting on happening some event which never happens, actually which never happens, which never happens, then we say these processes are are involved in deadlock sorry in deadlock state. Okay, so this is what the meaning of deadlock. This is to understand this in better way. Just see, I mean something like in real world we can understand it. Suppose the vehicles are coming from this side, this side, as well as from this side. Now, in this situation, if the car or the vehicle will try to cross the road from this side to this side or from this side to this side, so no one will be able to cross because one vehicle is here and another vehicle is here. So there is no way to move from this path to this path. And like the same way, there is no way to move from this place to this place. So this is the situation of deadlock. Like the same way, in deadlock, no process is able to execute. So what are the processes? So that's why it is written like two or more processes. So two or more processes may involve and causing that situation to deadlock. So this is what the meaning of deadlock. I hope you all have understood it in real. So let's move to the next, I mean, uh, next concept. So this is what the meaning of deadlock. Now, technically, we just try to understand what exactly causes deadlock when we are dealing with the process synchronization, especially using the semaphore, and that will be better for you to understood what causes deadlock actually whenever we are trying to synchronize one or more two or more processes so that there is never there is no chance of inconsistency. So let us try to understand what happens when we use improper when we are not able to use semaphore in proper way. So what is that means and how deadlock occurs? So let us say there are two semaphores, that is S and Q. Let us say there are two semaphores and there are two processes P1 and P2. So what happens in P1? Let us P1 executed wait instruction. wait S. Okay, these are the two semaphores. Initially its values are, its value, it has been started to 1. So wait has. The same time the P2 executed wait Q. Wait Q. Where, and these two semaphores, these are related with the two resources. I mean, just understood it like S is an resource, S is a resource, and Q is also a resource. So wait, and it has executed wait, and P2 has executed wait Q. Now next it tries to execute, I mean tries to acquire Q resource, wait Q, and it wait S. Now what happens? Just you can understand it, and after that it is the body. So after that it will perform signal signal S and signal Q, and this one will perform signal Q, signal S. So what happens over here? So suppose P1, so this is process P1 and this is process P2. So what basically wait S, initially wait S means S will be granted to this process P1 because the semaphore value is 1, it will down. As soon as it will execute this instruction, it will down the value and down the value from 1 to 0. Okay, now as soon as, let us say, the P1 arrives and it has decremented the value from 1 to 0. Now at the same time, if the P2 will try to decrement I mean S, it will not be allowed. Or in other language I can say that if P1 has acquired some resources and it is having a single instance and P2 is looking for the same resource and that has been granted to P1, we cannot grant it to P2 because it has been already acquired by P1. So the same situations can be, we can easily understood from these two semaphores, that is S and Q, they are just like a resource. So wait S is granted for P1. Now the same time P2 arrives and it has decremented the value, semaphore value from 1 to 0. So the Q has been granted to P2. Now what happens after that? If the P1 wants to acquire resource Q, that is, if it wants to decrement Q, it will not be allowed because it has been already decremented. And semaphore value, by in binary semaphore, we all know that it is it may be either 1 or 0. Sorry, it may be 1 it means allowed, 0 means not allowed. So it will not be allowed. So now what happens? So what P1? So P1 has acquired the resource S. So P1 and at the same time P2 has acquired resource Q. So now the situation is that if you will see overall observation, okay, so these two are conflicting and these two are conflicting. So what happened? So P1 is waiting for P2 to release the resource, I mean to signal later on, and P2 is waiting for P1 to release the resource so that it can execute itself. So this situation is known as deadlock. I mean, no process is able to move either P1 or P2. This is what the explanation of deadlock in terms of synchronization, and it also explains how improper use of semaphore leads to deadlock situation. So this is what the meaning of deadlock. Now let's move ahead and try to understand what are the deadlock characterization? I mean, what are the necessary conditions in which deadlock occurs? So to understand this, so till now we have discussed the deadlock. That is a process. Now you can relate the same to thread also. So a process or a thread is in a state, deadlock state, if if it is waiting for particular event that will not occur. So this is what the meaning of deadlock. Now, to understand what are the deadlock characteristics and what are the necessary condition of the deadlock, conditions. That is the four necessary condition of what? Deadlock. So to understand these conditions, these four necessary conditions, we must first understand that when a process needs a resource, how it actually uh, requests and what it actually acts to get to get the resource and to execute itself. So the process always um I mean does everything in this sequence. So what is that sequence? It always first requests for the resource, then it uses that resource, and after the use it release releases. So whenever I mean a process needs a resource, first it requests and use it and release. So these are, a process always needs something in the same sequence. It requests for a resource, it uses it, then it releases. This is what this is the, this is the way to a process behaves whenever it needs resource. Now what happens to understand what are the various situations in which causes the deadlock? These four necessary conditions which causes deadlock. Now to understand it, uh, let us know in deep way what are those conditions and how they causes. So the first condition is what? That is the mutual exclusion. First, mutual exclusion. Okay. And the second condition is hold and wait. Mutual exclusion, hold and wait. And the third is no preemption. And the fourth one is the circular wait. Okay, so these are the four conditions. These four conditions ensure that the deadlock will occur. Surely they occur. Among these three, that is one, two, three. These are the indirect causes. They are indirectly causing the deadlock. Indirect. And this is the direct. We always, whenever we are defining deadlock, we see that if there is a circular weight, then there is a deadlock. This is direct cause. Direct cause. So let us understand what is mutual exclusion and how it causes deadlock. So if you will see mutual exclusion, so mutual exclusion means I mean mutual exclusion. What mutual exclusion is? If there is a mutual exclusion, so the question is that if there is a mutual exclusion, so will the deadlock occur or not? Now, if there is no mutual exclusion, then deadlock will occur. So what we always try to uh, try to provide the resources in mutually exclusive way to prevent from deadlock. That is the another thing which we will discuss. So what is the meaning of mutual exclusion? Mutual exclusion says that suppose there is a resource, I'm saying that this is a resource R1 and this is a resource R2. So basically we are also understanding by everything by using the resource allocation graph. Resource allocation graph. In resource allocation graph, it says that it uses the various symbols. Like for resource, we use this rectangular box under the dotted. The dot says that it is a single instance or it is of multiple instances. So resource allocation graph says that this is the resource R1. So if the P1 is demanding for resource R1, suppose it is demanding for resource R1, okay, so mutual exclusion says that I mean if it is a single instance, so you can provide it to either you know any one of the process. Suppose the same time P1 is also P2 is also. So if P1 and P2 both are demanding for the same resources and resource is having a single instance, so you need to provide it in mutually exclusive way. If it is single instance, obviously it it could be provided to either P1 or P2, any one of them. But if you are not doing like this, you are not providing resources in mutually exclusive way, so then there is a chance of deadlock. Then there is a chance because the same time P1 will also demand and P2 will also demand. We will understand this basically. Okay, and maybe they causes P1 and P2 to deadlock situation, like we see previously in improper use of semaphore. Okay, so the same situation can be understood using this. So if P1 and P2 both are the processes and they need the same resource R1, so it must be provided in mutually exclusive way so that there is no chance of deadlock. Okay, this is for the single instance. Like the same way it can be applied to the multiple instances and how many processes are requesting for those resources. Okay, so this is what the meaning of mutual exclusion. If there is no mutual exclusion, then there is a chance of deadlock. This is what the meaning of mutual exclusion. So we need to provide the resources in mutually exclusive way. If there is no mutual exclusion, there is a chance of deadlock. This you must understand. Now the second one is hold and wait. Hold and wait. Hold and wait. Now what happens if we hold and wait? Suppose P1 is a process, okay, and it has been provided to the resource R1. Okay. Now the P1, now P2 is another process which is requesting for P1. Now there is another resource R2. So P1 R1 has been provided to P1, and basically R2 has been now R2 has been provided to P2. Okay, now P1 is requesting for R2 and P2 is requesting for R1. So what this means, see, this is what the situation, like same situation. The very first slide which we see, that improper use of semaphore, the same situation was happening. Basically this also explains the mutual exclusion also. So what is happening over here? P1 is looking for P2 to release the resource and P2 is looking for P1 to release the resource so that it can execute. Okay, so it causes the deadlock situation. If we convert this to the wait for class, P1 is waiting for P2 and P2 is waiting for P1 to release the resource. So hold and wait means if one process is holding a resource and looking for another one. Okay, like the same way another process may hold some resource and waiting for another one. Okay, so this hold and wait situation leads to the situation that is known as deadlock. So we have understood that mutual exclusion, hold and wait, how these two causes deadlock situation. Basically, all these conditions holds together. These all these four conditions holds together to cause the particular state in a deadlock. So this is what the meaning of hold and wait. Now the third characterization, that is the necessary condition of deadlock, is no preemption. No preemption. Now what is the meaning of preemption? Preemption means, suppose there is a process P1, okay, and it is having some resource, it is looking for some resource R2. Initially it holds some resource R1. So preemption means, I mean, it is holding some resource R1, it means it is in execution. So now, if we forcefully take away this resource R1, this is called preemption. I mean, resource preemption or process preemption. I mean, whatever we can understand. Preemption means here, here we are dealing with whether or not we are able to take away those resources which has been already given to the process. If we can take away those resources, then that is called preemption. If we can't, then it is called, I mean, it is means that resource is not preempted in terms of resources. Like the same way, we can understood it from any of the situation. Suppose you are having, you are having a pen. Now I need that particular pen, so I can interrupt you and just take out that particular pen, and I can start writing. I mean, this is what the meaning of preemption. I mean, you are having the pen as a resource. This is called resource preemption. Okay. So if there is no resource preemption, then there is a chance of deadlock. Why? As we have seen that if P1 is having the resource which is needed by P2 and P2 is having which is needed by P1, so this causes deadlock situation. I mean, if there is no preemption, if we can preempt any of the resource, either R1 or R2, then we can break this particular deadlock. Because if I will preempt this resource, so this resource preempt means that will be not used by uh, I mean P1 is holding, let us say P1 is holding R1. Okay, so if I am preempting this particular resource R1, so it means, I mean, I have just taken away that particular R1 from P1. So I can provide that to R2, R1 to P2. So P2 can execute because P2 is already having R2 and it needs R1. So I can grant this resource R1 to P2 by using the preemption. So P2 will execute, and after execution P2 will release the resource R2 as well as R1, and that can be provided to the P1. So no preemption means if we are not able to take away that resource forcefully, so there may be situation of deadlock. This is what the meaning of no preemption. Okay, so this is what no preemption is. Another third, these are the three indirect causes of deadlock. Now the fourth one is the direct cause of deadlock, that is circular weight. So circular weight is what? Circular weight. Now what is the meaning of this circular weight? As we see we have seen in our previous examples that P1 is waiting for P2 and P2 is waiting for P1. This is what the meaning of circular wait. Now the question is that is this circular wait, is this include all those three conditions which we have been already discussed? Yes. If you see that it may include, there is, mutual exclusion, because there is no mutual exclusion, that's why there is a chance of circular wait. Hold and wait, maybe one P1 is having some resource R1 and waiting for R2, so there is a situation of hold and wait. Now, no preemption is also there. We are not able to preempt any resources, either R1 or R2. And that's why there is a circular wait situation. That's why it is being said that these four conditions are the necessary condition for deadlock. These four conditions should occur together to cause a system into the deadlock state, and this is the final one. Okay, so and the circular weight, if there is a circular weight, then there is a, there is a deadlock, we say, whenever there is a single instance resource. For multi instance there is a different situation, we will understand. So I hope it is clear to all of you that what are the various conditions of deadlock. Now after that, if we want to understand how to handle these deadlock situations. Okay, so basically, if you want to handle, if you want to understand the various ways to handle deadlock. So first, way to handle deadlock, that deadlock prevention. The deadlock, we can prevent deadlock by some way. Deadlock prevention. Second way, we can use deadlock detection. Here we use Banker's algorithm. Banker's algorithm. Third way, I mean, we can use deadlock. Deadlock has been, we are finding the situation that the deadlock has been occurred, so we can recover from deadlock. How to recover? Deadlock recovery. Deadlock recovery. So sorry, I think there is deadlock prevention and deadlock divide. This one is deadlock avoidance. It is deadlock avoidance. This is what deadlock avoidance. And the third one is the then, so deadlock prevention, either we can prevent all the situation which causes deadlock, that is all those four condition, we can, we can try some way, we can enforce some rule so that these deadlock four condition should never occur. This is what the meaning of deadlock prevention. Now we can avoid the deadlock situation. Here we will apply some kind of algorithm that is known as Banker's algorithm. And the next is that we can also use deadlock detection. Deadlock detection and then deadlock recovery. So these are the various ways to handle the deadlock. So let us understood what is deadlock prevention and how we can prevent the situation of deadlock. So in deadlock prevention, what basically we are trying to do in deadlock prevention. Deadlock prevention, what we are trying to do, that those four conditions never occur. So what? So first condition is mutual exclusion. What happens? I mean, if there is no mutual exclusion, then there is a chance of deadlock. So how to avoid this mutual exclusion? So if this if the resources sorry if the resources can be put under a two head, that is the shareable, non-shareable. So what it means, if the resource is shareable, okay, so it means it can be provided to the, you know, uh, these are the two head number one. I mean, the entry one is shareable, entry two is non-shareable. So if the resource is shareable means it can be provided to the multiple processes, P1, P2 like that. But if the resource is non-shareable, what it means, it can be provided to one and only one. That means either P1 or P2. So non-shareable resources could be provided to only one, and shareable can be provided to more than one resources. So shareable means it is having the multiple instances. Obviously, it is having the multiple instances, and it may be provided to the more than one resources. So shareable means it can be shared, and non-shareable means it cannot be shared. Okay, so this is what the meaning of. Uh, in this way, we can avoid this mutual exclusion. I mean, if the resource is shareable, then obviously we can provide it to the multiple processor. If the resource is non-shareable, we cannot provide it to the multiple processor. That's all. In this way, we can avoid this mutual exclusion. This is what the solution of mutual exclusion. Okay. Now, the next condition, how to prevent from the next condition, that is hold and wait. Okay. So, in hold and wait, what was causing wet deadlock? Second was hold and wait. So we already studied that if the P1 is holding some resources and waiting for P2, and P2 is holding some resource and waiting for P1, so this situation lead to the deadlock. So how we can prevent this situation, hold and wait? The first solution is that, I mean, uh, provide all the resources in atomic manner. Atomic manner. What it means? Atomic manner means either provide it, either suppose P1 needs resources R1, R2, R3. So either provide all to P1 or none. This is what the meaning of either provide all resources to the P1 or none. This is what the meaning of atomic. So if you will provide it to the very initially all the resources to any process which needed all the whatever the resources that process needed, so then there will be no chances of hold and wait. Okay, and the second is that suppose, I mean, there are two approaches basically we use. The second approach, we can say that if P1 is having resources, suppose if P1 is having R1, R2, okay, and these resources, okay, and P1 to it is currently holding R1 and R2, and it needs some resource. It also needs some resource R3. I mean, it is holding, and it also needs some resource R3 needs. I mean, it is waiting. Okay, fine. So P1 is having resources R1 and R2, and it is needed, it also needs some resource R3. So basically this is the resource preemption. So what it says that either just release all these resources I mean, this is holded by P1, P1, and because it right now I mean, it is not having R3, so I can release these resources R1 and R2, which is already being held by the P1. Now, after releasing this, either I can entirely providing all the resource R1, R2, and R3 all together or none. This is something related with the resource prevention also. Okay. Okay, so what it means, if P1 is having some resource R1 and R2, it needs R3 also. So first release the resource R1 and R2, then allocate R1 and R2, R1, R2 and all three are together. So these are the two approaches by using which we can avoid this hold and wait. But the drawback of these two approaches are what? I mean, the poor resource utilization, and the second one is what? Second one is the starvation. So what are the drawback of these two way that I mean drawback of those two solutions we discussed? Drawback. So what? Poor resource utilization, and second, starvation. What it means? How? Let us say a process is having all the resources, I mean resources like suppose tape drive. Tape drive, we all know that it's a sequential device to read the data, read. Then disk, then I mean it has to read the data. Suppose a process P1 is what is doing? It is reading the data from tape drive. P1 is reading data from tape drive, then it is writing it to the disk, okay, then sending it to the printer. So these all are held by the process P1 at the very beginning. So initially what the P1 is doing, basically it is using the tape drive and disk, but this printer is not being used by this P1 because printer is a device which will be used later on by the process P1 to print something. But initially it is using only the tape drive and writing those data to the disk. I mean, suppose it is performing some kind of sorting operation to the data. I mean, reading the data from tape drive and sorting that to the particular disk. Okay, but later on it needs printers. But at the very beginning, it is holding all three. So wherever the printer is being needed, we cannot provide it to them because if it is a non-shareable, so we cannot provide this to the other, processes. This is what the meaning of poor resource utilization. Okay. Now the starvation is that, I mean, if this is the situation that leads to the poor resource utilization, so if the process P2, P3 needs that printer, which is being currently handled by the P1, so it may be chance that this process P2 and P3 is starved. I mean, they need the printer, but actually they are not getting the printer because every time some process, some high priority process or some processes are coming, and that is being the printer is being allocated to those processes, but the printer is not being allocated to P1 and P3. P2 and P3. So P2 and P3 are starving for what? Printer. Because of printer. Because they are not getting the printer. So this lead they so the solution which we already discussed caused to these two drawbacks, that is the poor resource utilization and poor resource utilization, we can easily understand it may lead to the situation of starvation also. Okay? Fine, because they are holding all the resources all together at the very beginning. This is the reason why it is poor, that is a poor resource utilization, and why it is why the other processes are starving for uh, some resources. Now, let us see the no preemption. So, what happens if there was no preemption? Then there is a situation of deadlock. So, what it means? What is the meaning of preemption? So, to eliminate no preemption, I mean eliminating no preemption, no preemption. Okay. So, what is the meaning of how we can eliminate this no preemption, which make us to the deadlock situation? Okay, so suppose we can relate. Suppose P1 is a process which is which is holding the resources R1 and R2. Now P1 also needs R3. Fine. Now some other process P2 with the highest priority. I mean, let us say it is having the highest priority. Priority is high. It needs resource R1 and R2. Okay. So what we can do? We can take away the R1 and R2 from P1 because it is having the lower priority than the P2, and we can grant that resource to the P2 which is having the highest priority. In this way, we can preempt the resources which is being held by the P1, and we can grant it to the P2 so that this high priority process can use the resource and execute by using that resource it can execute itself and later on can release the resource. So this is what the meaning of uh, I mean in this way we can eliminate this no preemption. So this is what how we can prevent from the deadlock. Okay, clear? Okay. Let us understand the final situation, how to prevent from circular loop. So what it means? P1 is waiting for P2, waiting for P3, dot, 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 dot. This is what the situation of deadlock, circular loop. Now, suppose there are three resources. I mean, resource number one, okay, which is having the priority 1, resource number 2, which is having priority 2, resource number 3, which is having priority 3. Now, if I need the resource, I mean, if the process P1 needs any resources, it must demand it to the increasing basis of priority. So it means we are providing each and every resource with the priority number so that if any process needs those resources, so they must demand those resources in increasing order of the priority. I mean, it could not be the situation that if the P1 has been provided to resource R2 and later on it is demanding for resource R1. This is not the situation. Okay, so providing the resource in the increasing of the priority means first P1 is demanding for R1, I mean R1, which is having the priority number 1. If this is the, I mean the greater the number, greater the, I mean greater the number, greater the priority, I mean highest priority, highest priority. So what it means? So P1 will first demand P1, then sorry R1, then R2, then R3. It cannot demand R2 first, then R1. It will always demand R1, R2, R3. So if any process is demanding the resources in increasing order of priority and we are providing the resources on the basis of that, then there is, I mean, the resource allocation graph will never, I mean, we can never face that particular situation in which the deadlock will occur because there is no chance, there will be no chance of deadlock because suppose P1 is waiting, initially what was the situation? P1 was waiting for P2, P2 is waiting for P3. Now P1 will be provided with the increasing order of priority of resources, like 1, 2, and 3, that is resource R1, R2, and R3. So suppose P2 needs R2, okay, R2 first. Okay, so what it means? Suppose it is holding R3, so it cannot demand for R1 because we need to provide P2 in the increasing order of priority. So it must need first R1, then R2, then R3. So in this way, the resource allocation graph will depict there will be no situation of deadlock. Okay. So this is what the meaning. So meaning means that order to request resources RJ, let's just say RJ, a process must first release all Ri such that I should be greater than or equal to j. This is what the situation. So in this way, we can eliminate all those, uh, I mean, those four conditions by this, by by all the means we have been discussed in this particular lecture. Now, then in next lecture we will discuss the safe and unsafe step. Then we will study the deadlock avoidance, that is Banker algorithm, and other related issues. Okay.